what if we want to open this chest, pick up this gun, or open this door? And what if we don't know how many types of interactions are going to exist in our game at this point in time? Like maybe in future I want to chop down a tree, or get in a car, or call an elevator. All of these are interactions. So let's build an extensible interaction system that will handle all our current cases and any cases that might come up in future. Before we write any code though, let's take a look at a quick design. Firstly, we'll need an interactor component. This will be the thing interacting with the objects in our world, so any characters in our game. And our interactor is going to be looking out for interactable objects. To define interactable objects in our world, we can use an interface. In C#, an interface is used to define a contract. So when our interactor finds an interactable object in the world, it knows that it is bound by the interactable contract. Then each of our interactable objects in our game will need to implement the interactable interface. So this will make sure that all of our objects like item pickups, doors, and chests are all bound to the interactable contract. And each of these objects will have their own logic defining what they need to do when they're interacted with. Nice, so that sounds like a decent and extensible design, so let's jump into Unity and get started. Okay, in our project, let's create an interaction system folder. Then inside of that folder, let's create two more folders. Firstly, we'll create one for the core system. Then we'll create another folder for each of the interactions. Inside of the core folder, let's define a monobehavior script that will handle our interactor. We'll call it interactor. We'll quickly drag it into our character once Unity is done rebuilding itself. So now our character has an interactor script. Then we'll create another script inside of our core folder, but this will just be a normal C# script. So we can go to scripting, empty C# script, and we'll call this interactable. Then let's double click it to open it up. We can delete the using Unity engine from the top. And we'll want to change this from a class to an interface. Then we can define our functions. Firstly, we're going to need a public Boolean function called canInteract. Then we'll need a public Boolean function called interact, and it will take an interactor as a parameter. This way, whenever something interacts with our objects in the world, we can do things with the interactor. Like in the case of the pistol, we can animate the pistol to move towards the object that is interacting with it. We'll save our script and head back to Unity. Okay, now back in Unity, let's go into our interactions folder and let's define our first interaction. We'll start with the door interaction as this is the easiest. So we'll create a new monobehavior script and we'll call it door interaction. And then we'll open it up in Visual Studio. Now, the first thing we're going to want to do is we're going to want to implement our interface. So to do that, we can type comma interactable after the monobehavior definition. Now you'll see this will throw an error, and that's because we're not abiding to the rules of the contract. So to fix that, we can hover over it, click the little light bulb and say implement interface. Then we'll see this will create our two functions that we defined in our contract earlier. For now, we can delete the start and update methods. And I'm going to be using doTween to do the door interaction. So if you want to, you can take a look at this doTween video tutorial I made earlier. Firstly, we're going to need two variables just to keep track of how we want the door to rotate and how fast we want it to rotate. So we'll create a private vector3 target rotation, and we'll set a default value of vector3 0, -100, 0. And that might be wrong, but we can always change it in the Unity inspector later. And then we'll create a private float called rotation speed. And we'll set this to 3 for now. Next, we'll need a variable to keep track of if the door is currently open or if it is closed. So at the start, we'll set it to is open false. And because the door can always be interacted with, we'll just return true here. Then in our interact function, we're going to check if the door is opened. Then we need to close it again. So we can do transform dot do rotate. And we want to rotate to the negative of the target rotation at the rotation speed. And we'll use rotate mode dot world axis. And if the door is currently closed, then we just want to do the same thing, but we want to rotate to the positive target rotation vector. And then finally, we just want to set is open to not is open. So if it's currently open, it will set to false. And if it's currently closed, it will set it to true. And then we'll just return true at the end of this interaction. Cool. So let's just head back into Unity and add the door interaction to our door before we forget. So we can just drag in the door interaction to our door game object. We'll hit save, and now we want to actually test this out. To test this out, we need to implement our interactor. So how we're going to test if our door interaction works is we're going to cast a ray from the origin point of the interactor. So that would be the origin of the character, and test if the ray hits any interactable objects. If it does, we're going to check if the interactable object can be interacted with, and if it can, we're going to interact with it. So let's jump right into getting that done. Firstly, we're going to want to track how far we can cast a ray. We'll create a float variable, and we'll call this cast distance, and we'll set it to 5 by default. Then we're going to want to keep track of an offset so that we can cast the ray from the midriff of the character rather than from its foot to avoid any unwanted collisions. So to do that, we can create a vector 3, and we'll call it raycast offset, and we'll set it to a new vector 3 of 0, 1f, 0. So this will be about halfway up the player. Next, we're going to create a function called do interaction test. So we'll write private bool do interaction test, and this will output an I interactable. Now, because we're using an output variable, this function will need us to initialize it. So we can initialize our parameter by saying interactable equals null. And next, we're going to want to define our ray. So to do that, we can write ray equals new ray. And we can pass in our transforms current position, and we'll add in our raycast offset. Then we want to cast this ray in the forward direction. Next, we want to actually perform the raycast. So to do that, we can type if physics.raycast, and we'll pass in our ray as a parameter. We can say out raycast hit, and we'll call this hit info. So if something is hit, this function will return something inside of hit info, and then we'll pass in the cast distance we defined earlier so that our ray doesn't go too far. Let's close that properly. And then we can just set our interactable equal to the hit info dot collider dot get component I interactable. Did not spell good. Cool. There we go. So what this is going to do is it's going to cast the ray forward. If it hits something, it's going to store that in the hit info. And then we're going to check if the hit info's game object contains any interactables inside of it. If it does, then we know that something is inside of our interactable. So we need to check for that. So we'll say if interactable is equal to is not equal to null, and we know that we've hit something, so we can say return true. And because that passes, we're storing this inside of the output variable. So whatever calls this can just use the interactable from there and call the interact function. But if it is null, then that means we didn't hit anything interactable, so we can just return false. And if the raycast completely missed, we also want to return false. Now in our update function, we need to just test if the player presses the interact key, which in this case will use the F key, get key down, key code dot F. Generally, I would put this input code inside of a player input handler, but for this example, I think this should get the point across. So if the player does press the input key, then we want to test the interaction. So we can say if do interaction test, and then we want to output an I interactable, and we can say if the interactable dot can interact, firstly, then we want to interactable dot interact, and we need to pass in this as the interactor. So that should be everything we need. Now, if we head back to Unity and hit the play button, we'll also see, because we added the interactor to our script earlier, we've now got each of these properties. So if we walk up to our door and hit F, there we go, our door opens up really slowly, but it opens nonetheless. So let's just fix the speed of this interaction. We'll change this rotation speed to like 10. Oh my gosh. Oh, that's actually a rotation time, not a rotation speed in between. So that actually means we want that rotation to take 3 seconds. So we'll just update that so that the rotation actually only takes 1 second, which still might be a bit slow. Yeah, but that's not so bad. But anyway, so now that's working as expected. So what happens is when I hit the F key, we cast a ray forward, we're hitting the door, and because we've hit an interactable object, it will get the interactable and perform the interact function. So right now, nothing will happen if we do the same thing at our gun and our chest, but let's fix that. Future me here, make sure your interactable objects have colliders. It's important, otherwise the raycast will miss. Raycasts hit colliders, important. So the next one we'll do is let's write the chest interaction. So we'll go and create a new C# monobehavior script called chest interaction. And we'll just take a look at our chest parent. Now, the way I've set this up is that the chest is going to be using an animator. So this is a completely different setup to our door. But we'll drag in our chest interaction script and we'll take a look at our chest animator real quick. So our chest animator has a parameter called open, and when the open parameter is set to true, then the chest will play the open animation. So that's important for us to know when we set up our chest interaction. Let's open up our chest interaction in Visual Studio. Next, we'll need to implement the I interactable interface. And we'll just hover over it and implement the interface. We'll also just remove the start and update functions. Now, with the chest, we can only interact with it once when it's never been opened before. So to keep track of that, we'll create a private bool called has interacted. And we'll say false by default. Now, can we interact? We can only interact if has interacted is false. So if not has interacted, return true. Otherwise, we can return false. And now in the interaction, we're going to need to get our animator component from this chest interactor. So let's create a new private animator underscore animator. And we'll bring back our start function. And in the start function, we'll just say animator equals get component animator. And then in our interaction function, we just want to call animator dot set bool. And this was called open to true. I think it was called open. Let's just double check. Yep, that's called open. We set it to true. And then we want to set has interacted to true. And we want to return true as well. Cool. So let's hit the start button and see if that works as expected. So now we walk up to our chest and nothing is happening. So how do we debug what's going on here? So does our chest parent have a box collider? It does. Box collider is quite low down. So there's a good chance that what's happening is we're actually just firing our ray above the box collider. So a good way to test this out is we can go back to our interactor. We can actually draw the ray that we're casting so that we can see it during a gameplay by typing debug.draw ray. We'll actually do this inside of the interaction test. So after we define our ray, let's call debug.drawRay, and then we need to pass in the ray.origin, and we need to pass in the ray.direction. And then we'll pass in color.red, and we'll show this for, let's say, 3 seconds. Right, so now if we hit play again, and we take a look at this, our array, we cannot see our array because our gizmos were off. So now if we take a look at this, we can see that our array is actually quite short, and it looks like it's going just over the box collider for our chest. So to fix that, let's just increase the size of our box collider on our chest. So we'll just slide that up a bit. Slide this over so that the collider matches a bit better. Now let's see if that fixes our problems. Boom, there we go. So that does fix our problem. All right. And then the last thing is this gun. So this one will be another do tween animation, but it's a good one to look at because it will make use of the interactor. So again, in our interactions folder, we're going to create a new mono behavior script. We'll call it item pickup interaction. And again, we're going to implement our interactable interface. And inside of this, we're going to implement the interface. And so firstly, we're going to need a variable, a Boolean variable, to check if this object has been interacted with. Has interacted equals false. Then we'll say if underscore has interacted, return false. Otherwise, we can return true. And then when we interact with this, we want to say transform dot. What we want to do is we'll do a transform dot do move, and we want to move it towards the interactor, so the player, which we have conveniently got a parameter for thanks to our design. Transform dot position. And we want to animate this at, we'll add a speed variable so that we can change this. Private float animation duration, and we'll say this will be pretty quick, so we'll say like 0.5 f. So we'll do our move, and we want this to happen animation duration. And why is everything broken? Because we managed to delete our curly bracket. Cool, so now we've got our animation duration in here. And then we also want to do on complete. We want to set this, we want to destroy this game object. So generally you'd want to object pool this and disable it and re-enable it, but for the purposes of this example, I'm just going to delete it and then return true on complete. Right, so we can save that. And back in Unity, we'll select our gun. On our pistol parent, we're going to want to add the item pickup interaction. And we'll also just check the collider. Cool, that's got a really big collider, but that should be fine for now. But we'll increase its height a little bit. And let's press play and see what happens. Cool. So now when we interact with our pistol, it comes to the player. When we interact with our chest, nothing happens. Oh, there we go. I just needed to be looking at it. And when we interact with our door, that works as expected. Cool. So that's a pretty good interaction system. I think one final thing we'll do is we'll just enable some UI when the player is currently looking at something that is interactable. So I've created a little game object called interaction UI, and this is literally just a block with some text inside of it. It's a rect image with some text inside of it that just says press F to interact. And what we're going to do now is in the interactor, we're actually going to perform our interaction test every frame. And if we are looking at something that can be interacted with, then we're going to display our UI game object. And if not, we're going to hide our UI game object. So let's serialize field and we'll get a private game object interaction UI. And then in our update function, we're actually going to change things around a bit. So we're going to say, we'll delete our input check there for now, because we want to do our interaction test irrespective. Sorry, if we can interact with this, then we want to set our interaction UI to active. So we'll call interaction UI.setActive to true. But we only want to do the interact if the player presses the input key. So we can type if input.get key down keycode.f. Then we want to do this interaction. But if we're not if we cannot interact with anything, see, we want to disable our interaction UI. And if we completely miss our interaction test, we also want to set the interaction UI to false. So back in Unity, we can now go to our character, which has our interactor on it, and we can drag in our interaction UI script here, our interaction UI game object rather. Now, if we hit the play button, when we look at things, the interaction UI pops up and we can see that we can interact with them, which is pretty cool. Something to note here though, you do probably want to add a layer check on your interactor component so that if you're interacting with complex geometry, you don't kill the performance of your game. But overall, you should be good if you're dealing with simple colliders and not overly complex and overly full scenes. Anyway, this has been the interaction system tutorial. I hope you've enjoyed it. Please leave a like if you have, and I'll catch you on the next one.